So yesterday I asked you to take a look at the lava lamp. And I asked you to, first of all, I asked you to draw it, and I think we got that all taken care of. But you drew something that showed it was going up and then coming back down, and arrows repeat showing that that was a repeating pattern. Can you explain how a lava lamp works? Wait, does actually anybody have a cool explanation of why it works besides the real one? No, you're gonna tell me the real way? Magic, okay. Yeah. Okay, so we got the lava lamp. We got the. Okay, it is oil. That is oil in the lava lamp. So this isn't water. It is oil. It would kind of work with water too, but you wouldn't get that. It would look more like this one if it was just water. In the real one, it kind of goes. I thought it was air. Yeah, no. So we got oil is the pink. Is like I think the pink, and then or is it purple? I don't know. I guess it's purple, and then the pink is wax. Wax? Yeah. Oh. Okay, so the heat in the bottom. We got heat in the bottom. It's just the lamp. It's the light bulb. It off and they all fall. Well, they do start to fall. It does take it a while to start to fall, but yes, they do start to fall because it gets cold. So heats it up at the bottom. Then what happens? Heat rises. Heat rises. You guys all know heat rises, right? Then it gets cold at the top because it's farther away. That doesn't get cold, like I don't notice a difference touching the top from the bottom, but it's colder apparently. And so it gets cold at the top, and so it sinks. Why? Oh, density. Look at that in the big bubble on the bottom of page 9. Title that. Convection. And give me these 4 bullets at the bottom. So the whole bubble itself on the bottom there is titled convection. And these are the 4 bullets you got to have in that bubble. So first of all, it starts with exactly what you guys said. Wax heats up, but what you should remember from September, I think, maybe early October this year, is when you heat something up, the molecules spread out, they expand, making it less dense. We already know that less dense things float. You ready, miss? No. Then just like you said, just like Dalton added, when it gets to the top, it starts to cool. Then again, from the beginning of the school year, as it cools, it contracts, meaning it kind of huddles together, making it more dense. And then the process starts all over again. There should be no conversations. Convection is something we're going to be talking about several times this year. Because convection happens all over the place. Can you guys think of some places in, not necessarily earth science like, but real life that you've noted, or that you know convection happens, warm stuff rising, cold stuff sinking? When you make rice, or when you boil any water for that matter. When you boil water, can you picture the bubbles? You can't picture the bubbles in boiling water? Then you need to help cook more often. But the bubbles, where do they start? At the bottom. And then they go up because the flame is at the bottom where the heat is. So the bubbles go up, they cool off, and then they go down. Can you think of some other times you've noticed or know about convection happening?
Oil in my Italian dressing.
No, well, that's not convection. That's just density. It's just the less dense thing floating. When you heat your house. So whether it's a fireplace, if you got fireplace, the smoke goes up. If you have basically any type of heating, it's always warmer near the ceiling. We just got a brand new furnace in our little sunroom area, and it just heats up that little room because the room's so little. It's really, really, really hot at the top. Make sure to turn our ceiling fan on in a little room so that it would push some of the hot air down and keep the rest of the room cooler or warmer, sorry. Any fire, you should know if your room fills with smoke, what should you do? Okay, you go down. No, see, that's no. If your house is filled with smoke, you should not be rolling around on the ground. So this is a good public service announcement. Please do not get stop, drop, and roll that confused with crawling out of a room filled with smoke. Okay, so if your house is filling with smoke, don't roll around on the ground. That's if you catch on fire. So I'm glad we cleared this up in case anybody needed this in case of emergency. All right, so moving on. So what does this actually have to do with what we've been talking about? Why am I talking yesterday about continental drift and Alfred Wagner? And today I'm talking about a lava lamp and coal rolling around on the ground. Because this is, remember yesterday in the song, and if you don't remember, I'll play it again. Oh, I will. If you remember in the song, they said, Alfred Wagner, you crazy little man. What did he have why did they call him crazy? No, it wasn't because he was short. It was because he had no how and why. If you remember, they said, you have no how or why, you crazy little man. They didn't say he was crazy because he was a little man. What? No, his hair was fine. They were not making fun of his hair. Yeah, that's the wrong guy anyway.
They didn't like him because he was smart.
Anyway, they called him a crazy man because he had no proof. He had no how or why. He had some good examples, but they're like, dude, that could never happen. Continents can't move. It wasn't until they discovered that there was convection happening in the mantle. So there was convection happening in the mantle, very similar to what's happening, or exactly the same as what's happening in the lava lamp, but just on a much bigger scale. So it's happening, again, we've got warm mantle rising, hanging out at the top for a little bit, and then sinking back once it gets cool. Just like the lava in the lava lamp. Warm lava rises, hangs out at the top a little bit until it gets cold, it sinks back down. Well, this upward, and it's kind of in a constant circular motion. This motion, this up and down in a circular path, is actually a lot like a conveyor belt. So this same process, where it's going up, down, and around, is a conveyor belt underneath the ground. And it's just moving around and around and around. The conveyor belt, convection currents, are going to move whatever's on top of them. Just like a conveyor belt at the grocery store moves your groceries down the path. It's going to move the continents with it. So in this case, conveyor belt's going this way. These guys are going to end up slamming together. So convection in the mantle is what's actually moving the continents around. So right at the top of page 10. Yeah, go ahead. This one?
Yep. So the arrows go out and then down and around.
Yeah.
So where they go down and around, there's the one like hold it in.
Yep.
Mountain, when two plates hit each other, they go up, face mountain.
Mhm.
Are there underground mountains?
So you're actually now, we're going to be talking about this in a couple of slides. So when they hit, yes, one can go like this, but there's also places where they just pull apart. Is that what you mean?
I mean, when they hit, can they, instead of going up, go down?
Oh, yeah. I'm sorry. You did say that. I did see your hand motions, but then I got distracted. So when and this is what we're doing all Monday. But when two continents come together, they make a mountain. But when a continent hits an ocean, they go underneath each other. And it's not an underground mountain. It would actually be like a trench.
Yeah, but like when a mountain goes like
Yeah,
that,
no, like
can it go like
They
that?
don't both go down. So there's no time when one will go, they'll go like this. There is a time when they go like this, and it kind of creates a ditch like right here. That would be a
Do you
trench.
want me to leave the desk out there?
No, Drew will be happy to bring it in. So where were we? So this goes at the very top of page 10 if you don't already have it. Very, very top of page 10. convection currents within the asthenosphere move the plates. So just like the conveyor belt, the plates are gonna move around the top because they basically are riding around on the conveyor belt. Where'd it go? All right, everybody got that? So the convection currents, to make sure you know what convection currents is, it is when heat, when it's a transfer of energy. Gotta be. There may have been an easier way to do it. Anyway, let's keep going. So it is the transfer of energy. I say it's when hot stuff, and I know your ELA teachers don't like using the word stuff, but it's when hot stuff rises, cold stuff sinks. I say stuff because it happens in the air, it happens in water, it's happening in the mantle. So it's not just one thing that this can happen in, it's happening all over the place, even in this room. The hot air right now is rising. Everybody got this besides the delinquents that just came in?
No, I didn't get it.
Okay, delinquent that's been in the room the whole time, can you get this now? All right, I'm gonna keep going. When we've got these currents that are going up, so in just like this example, what's gonna be happening to the conveyor belts? Which way are the conveyor belts gonna be moving? So in this case, since they're going this way, they're going to be moving out from where they are. So like this one. So in this case, where it's the rising currents are going to cause the conveyor belts to go out. Meaning, what's going to happen to the stuff that's on each belt? They're going to be moving. Which way are they going to be moving? They're going to be moving away from each other. So they're going to be moving apart. Rising currents cause the plates to move apart. And then falling currents. So at the same time where you have rising currents in one area of the earth, they must be falling somewhere else. So the places where they're falling or sinking, these can, and I don't have a picture that shows the conveyor belts, but you can imagine a conveyor belt on top of this arrow. Where they're sinking, that's where the plate contents are going to be moving together. So the falling currents is where they're moving together. You got that already? All right. And that is actually all I needed to get done. So I didn't know how long the quiz is going to take. So this is as far as we got. No homework again today.